Today we're going to be classifying quadrilaterals. So, a quadrilateral with both pairs of opposite sides parallel, so opposite sides are parallel, that is called a parallelogram. A parallelogram with four congruent sides, so that means it still has opposite sides are parallel, but all four sides are congruent. That is called a rhombus. A parallelogram with four right angles, so we still have opposite sides are parallel, but we have four right angles. That's called a rectangle. A parallelogram with four congruent sides and four right angles, so meaning it still has opposite sides are parallel, four right angles, and four congruent sides, is called a square. A quadrilateral with two pairs of adjacent sides congruent and no opposite sides congruent. So adjacent sides are congruent, and we have two pairs, and that's called a kite. A quadrilateral with exactly one pair of parallel sides is a trapezoid. And a trapezoid whose non-parallel sides are congruent is called an isosceles trapezoid. So let's figure out which Venn diagram is incorrect. So we are looking here, we say a rhombus, can a rhombus be a parallelogram? Well, to be a parallelogram, we have to have both sides are parallel. Both pairs of opposite sides are parallel. And in a rhombus, both of our opposite sides are parallel. So this is a true statement. Now let's look at this one. Can a square be a rhombus? Well, in order to be a rhombus, that means we have four congruent sides. And a square does have four congruent sides, so this is true as well. So let's look at this one. A rectangle, can it be a square? Well, a square has four right angles and it has four congruent sides. We know a rectangle does have four right angles, but it does not have four congruent sides, so this is false. So then our last one, can a kite be a quadrilateral? Well, to be a quadrilateral, that means it has four sides, and a kite does have four sides, so this is also true. We are going to look at this and classify our quadrilateral, and we're going to judge by its appearance. So let's take a look. By judging by appearance, well, we know it's a quadrilateral because it has four sides. Looks like it could be a rectangle. Parallelogram. Doesn't look like it could be a square because these sides look longer than the other two. So that means it can't be a rhombus. Since it looks like there's two sets of parallel sides, it's not a trapezoid. And since adjacent sides are not congruent, it can't be a kite either. So it looks like it could be a quadrilateral, a rectangle, or a parallelogram. Alright, let's take a look. And we want to find the values of x and y, and then find the lengths of each side. So looking at this, we're working with a kite. So since the kite has two sides that are adjacent, are congruent, these two are congruent sides. So we can say that y minus 3 equals 6 because they're congruent. So if I add 3 to both sides, I know y equals 9. So I found y. So now to find x, we can take our other two pairs of congruent sides. So we have 2x plus 3 equals y plus 2. Now in order to solve this, we know what y equals. Y equals 9. So I can substitute 9 in for the y. And 9 plus 2 is 11. So then we subtract 3 to both sides. So 2x equals 8. When we divide both sides by 2, x equals 4. So now that we found x and y, we can find the lengths of each side. Well, since we know this one is the length of 6 and it's congruent, this one has to be 6 as well. which if we just double checked our work, if we took 9 minus 3, 9 minus 3 is 6. So then to find this length, well, y is 9, and we know 9 plus 2 is 11. So this is a length 11. This one, since it's congruent to the adjacent side, it's also 11. If we checked our work, well, we had 2 times 4, which is 8, and 8 plus 3 equals 11. So we found x and y, and then our 4 sides. So in example 4, we have an isosceles trapezoid. An isosceles trapezoid, remember, we have one set of sides are congruent, and the other two are parallel. A and B are a leg, and C and D are also leg, and BC is our base. So if AB is 5y minus 10, BC is 6y plus 2, and CD is 2y plus 8. We want to find the value of y. So in order to do that, we know using these, we don't need to use this information because the base, it doesn't pertain. This one though, since these are congruent sides because it's an isosceles trapezoid, we can set them equal to each other. So 5y minus 10 equals 2y plus 8. So then from here I can add 10 to both sides. So 5y equals 2y plus 18. Subtract 2y. So we are left with 3y equals 18. When we divide both sides by 3, y equals 6. Alright, we need to graph L, M, N, and P. L is at the point 0, 0. Where'd it go? Sorry, L. M is at 3, 4. So we go over positive 3 up 4. N is at 8, 4. And P is at 5, 0. So then when I connect, this is my quadrilateral I'm working with, and we need to find and identify the precise name. Well, right now it looks like it's a parallelogram, but we want to see if it can be any more precise. We know it can't be a square because we don't have right angles. It can't be a rectangle because there's no right angles. Could possibly be a rhombus. We know it's not a trapezoid because it has two sets of parallel sides. And it's not a kite. So these are our two options, parallelogram or a rhombus. So we know from L to P we have a distance of 5, and from M to N is also a distance of 5. So we need to find the distance from L to M and P to N. So what we can do, to use our Pythagorean theorem, I know this distance is 3 and this distance is 4. So if we look at the Pythagorean theorem, we had a distance of 3 and 4. This is from L to M. So this is where we say, well, 3 squared plus 4 squared is 9 plus 16, which is 25. So when we square root 25, the distance from L to M is 5. And we know this one has to be the same, because if we do the same thing, we're going to end up with a triangle with a distance of 3 and 4. So this is also a distance of 5. So since it's parallel and all sides are congruent, our precise name for this quadrilateral is a rhombus.